We've been talking in recent weeks about various types of chemical reactions, and the last one we've discussed was combustion reactions. We've done some combustion reactions before in class, the gummy bear demonstration, the Pringles can, those were two good ones. And each of those had something in common. They needed something to help them get started. So we're going to do a combustion reaction today with a little bit of a twist. We're going to show how you can help these chemical reactions get going. So for any combustion reaction, we need two things. We need a fuel, which I've got here. This is called sodium potassium tartrate. So we're going to go ahead and add that to this large graduated cylinder. I also dropped a stirring rod in there, so we're going to turn the stirrer on to get this thing to mix. And we'll also turn a light on so that you can see what's happening in there. Now for our oxygen source, we're going to use hydrogen peroxide. Hydrogen peroxide produces lots of oxygen. So let's go ahead and add that to it. And you'll notice nothing happened, because we need something to help the reaction to get going. And that something is called a catalyst. We have a catalyst here called cobalt chloride. Now the neat thing about catalysts is they are not destroyed in chemical reactions. They help the chemical reaction along, but at the end they can be recovered in their original form. And we're going to be able to see what's happening by looking at the various colors in the reaction. So watch carefully what happens to our bright pink cobalt catalyst once the reaction begins. It's already beginning to change color, telling us chemical reactions beginning to occur. And we're also seeing a lot of bubbles forming. I've got this overflow dish here just in case the bubbling gets a bit too violent. It's now become sort of an amber color. The reaction is really going to town now. As you can see, lots of bubbles forming. Those bubbles, of course, are carbon dioxide, which is one of the products we normally get in combustion, that along with water. Eventually, the cobalt catalyst becomes sort of a lovely green color. That's the form it takes while it's helping the chemical reaction along. Once the reaction is done, of course, the cobalt should return to its original form, and we'll be able to tell that by watching the color. So now it's reached that peak, lovely green color. It may make it over the top, but I may have just planned things perfectly. We may get close, but not quite go over, because the reaction should be done pretty quickly. You'll know when it's finishing when the bubbles begin to subside, and there we go. The bubbles are starting to drop down. The catalyst has done its job, and now it should return to its original form. We're back to amber, and then very quickly it goes back to that original pink color, which tells us that the catalyst has done what it's intended. It changed while it was participating in the reaction. Now it's gone back to its original form. We could use it again. If I added more fuel, more oxygen, that reaction would take off again just as it did the first time.